All right, in this video, we're going to take a look at the Chapter 5 practice exam. So let's just jump right into it here. So question number 1, solve the system by graphing. So on this one, I look the other way if you're getting the solution in some other method. So, like when I look at this, I'm thinking real easily, you could just add these together, the y's cancel out. That'd be an easy way to get the solution. However, to get full credit for the problem, there needs to be a graph over here illustrating where the solution is located on the graph. So how you get the solution is up to you, but you need to show the graphing aspect of this problem in order to get full credit. So the way you're supposed to do this problem is to take each equation, graph it on the Cartesian coordinate system, both of them, and look for where the graphs intersect each other. The quickest way to graph these equations is to take the x and y intercepts would be the quickest way. So there's one equation, x plus y equals 3. The other equation is x minus y equals 1. To find the x and y intercepts, we will plug in 0 for one of the variables, solve for the other one. And what's nice about that is you can do this pretty quickly mentally without having to plug. So for the x-intercept, we will have 0 for y, right? You choose 0 for y. When you plug in 0 here for y, that term just goes away. You get x is equal to 3. So it just falls right out of that. You don't even really have to do any work, as long as you can see it that way. So I'm going to undo the marks I just made because we want to use this equation again for the y-intercept. But when I plug in 0 for x, I said the wrong letter. When I plug in 0 for y, I get x is equal to 3. And so that gives me 1 point. To find the y-intercept, we will plug in 0 for x and then find out what y is equal to from the equation. So when I plug in 0 for x, that term goes away. We get y is equal to 3. Right. And so we get these 2 points. And with 2 points, you can graph this because it's a linear equation. You just need 2 points. So we have 3, 0. We have 0, 3. That gives me these 2 points. With those 2 points, I can draw my graph. I can draw my line. All right, now you want to draw this line as accurately as possible. This straight line drawing tool doesn't always do the best job. And especially since I'm kind of splitting it in half, the halves may not match up as well as we would like. So I think it's supposed to look like that. It looks a little broken, but the slope is 1, so it should be going up 1 to the left 1 or down 1 to the right 1. It looks like it's doing that, but for some reason the line doesn't look quite right to me. All right, hopefully it doesn't get in the way of us finding the right answer. And so especially now if you're doing this on Math Excel, the line gets drawn perfectly. You shouldn't have any issues. But if you're doing this on paper, you want to make sure you draw that line as good as possible. All right. Same thing here. We're going to do x-intercept, y-intercept. Okay, that was kind of weird. I'm using the line drawing tool instead of the freehand thing. Okay, x-intercept, you plug in 0 for y. That makes that go away. You get x is equal to 1. All right, so you get 1, 0. That would be this point right here. For the y-intercept, we got to be a little more careful. This is going to be the most difficult one to do. You plug in 0 for x. That term goes away. You get negative y is equal to 1. So you have to solve it by dividing the negative 1 to the other side. You have to divide the negative sign to the other side, however you want to say that. But you get y is equal to negative 1. All right, so we'll get negative 1 for y, which is going to be right here. And you can see we're going to get a pretty immediate intersection. So draw with a straight line, but because the points are so close, how do I want to say this? The points we use to graph these lines are so close together, and the intersection occurs so close to those points, it would be hard to draw it in accurately enough not to get the right answer here. So even though this might be off the mark up here, the solution's occurring somewhere in this neighborhood, and this should be drawn fairly accurately since we haven't gone too far away from these points yet. All right, so let's try that again. So it looks like it should be about right there. And I'll just draw it in this direction, but we don't really care anymore about what's happening over here because what we were interested in is where the graphs intersect. And we can see that pretty clearly right here. They intersect at this point, and the coordinates for that point look pretty easy to determine. It's 2, 1, right? 2 for x, 1 for y. That's where they intersect, so that is the solution to the system. Right? So that's the way you're supposed to do that problem. You could double check by plugging it in just to make sure it actually works in both equations. So 2 plus 1 gives me 3, 2 minus 1 gives me 1, so it does work in both equations. All right, let's look at the next example. So here we're being asked to solve this system by substitution, which incidentally is the best way to solve it. So not only is that what the directions say, but it's going to be the easiest way for us to do the problem. Now, to solve by using the substitution method, you have to solve one of the equations for one of the variables. So I'm going to take the top equation and I'm going to solve it for y, not because that's what you have to do, but because that's the easiest thing to do. So what you do have to do is solve one of the equations for one of the variables, but it's your choice which equation you use, which variable you solve for. So I'm looking for the easiest path. And the easiest path to me, it looks like it's going to be solving this for y. I can do that pretty easily by just adding the 6x over to the right-hand side. And so I'll get y is equal to 11 plus 6x when I solve the top equation for y. Now that I have it solved for y, I want to plug that into the bottom equation. So make sure you plug it into the other equation that hasn't been used yet when you do this. I will occasionally have students who plug it right back into the same equation they just got it from, and that most likely leads you to the wrong conclusion. So I'm going to plug it into the other equation that I haven't used yet. So I'm going to copy this down over here. I have 6 times x plus 1, which, by the way, if they're using parentheses and putting things on opposite sides of the equation, they're trying to hide something from us. And we're about to see what that is here in just a second. Equals, in place of y, I'm going to have 11 plus 6x. So I'm finding out y here is equal to 11 plus 6x. I'm going to substitute that in for y here. So 11 plus 6x in place of y. But then don't forget you still have the minus 5 in this equation. So now I'm going to put the minus 5 here. So here's where the y was located. I replace the y with 11 plus 6x. All right, then we go to solve this for x. So I'll start by distributing the 6 into the parentheses. So I get 6x plus 6. Over here I combine like terms. 11 minus 5 is also going to be 6 plus 6x. And this is where you can realize the thing that's happening, which is really you're getting the same thing twice, which really means this is the same equation twice. That's what they were hiding over here. They scrambled it up so they would look different from each other, but really the top equation is the same as the bottom equation. And I know that because the left-hand side matches the right-hand side over here. So you could stop right here. But if you wanted to keep going, what I would do next is try to get the x's on the same side of the equation. So I subtract 6x from both sides. They happen to cancel out from both sides of the equation. So I get 6 equals to 6. I said that kind of funny. I get 6 equals 6, which should be enough evidence. But if you insisted on continuing, you would subtract 6 from both sides, and you just get everything goes away. You get 0 equals 0. So if you ultimately get 0 equals 0, or if your variables completely cancel out and you get something that's true, this is usually where I like to stop, and I see that this is true, that tells me that I have a dependent system. And it tells me that I have an infinite number of solutions. And if that's the case, you want to select option B here. Option A is if you just have one solution. You select option A. Option C obviously is when you have no solution. But when you get something true here, or if you get 0 equals 0, that means you have infinitely many solutions. So you choose option B, and it's set up to say this, that the solution set is any x comma y such that y equals blank. And so you still need to specify, because as I mentioned in the video in section 5.1, that just because there's infinitely many solutions doesn't mean that any ordered pair works. So it's a common misconception that students have. They think when there's infinitely many solutions that anything is a solution, and that's still not the case. This equation has infinitely many solutions, but 0 comma 0 is not one of them, right? If you plug in 0 for x and 0 for y, it still doesn't work. And so that isn't a solution. So you still have to specify, even though there's infinitely many solutions, what are those solutions like? Because it's not just anything that you want. And so we want to write the equation here, that it's any ordered pair that works in the equation. That will be a solution to the system of equations. And so the equation here is y equals 11 plus 6x. All right. And so that is the proper way of handling this question here. Now, this is a practice exam. However, I do know that number 2 on the test has 2 alternate questions. There's 2 possibilities. One possibility is what we've just seen here, that you get an infinite number of solutions. But don't assume that will be the case on the exam that you get, because there is an alternate question that does have a solution. So you would still solve it by the substitution method, but when you solve it, you actually get it to work out and there is a solution. So don't just memorize that for number 2, it's dependent, because that might not be the case. It might be the case 50% of the time, but you might have the other case on the test that you get. All right, let's take a look at another example, number 3. All right, so in this example, we're being asked to solve the system of equations by the addition method, which remember is also called the elimination method. Be careful with this one because they scrambled it up as well. Notice the first equation is 4x minus 6y equals 12. And the bottom equation is 6y minus 4x equals 3. So they wrote the variables in reverse order. Some students don't notice that and they solve it as if this was an x here. And I have no idea how well that would work out. What you want to do is rewrite these so it's in the same order as the first equation. So we're going to rewrite this with x going first. It's negative, so we're going to have negative 4x and then positive 6y equals 3. And when I add these together, because I guess I kind of skipped a step, but what you want to do is make sure a variable is going to get canceled out, but I can see right away that's going to happen. So I go ahead and add these 2 equations together, and not that I intended for this to happen, but what happens is both variables cancel out. The x's cancel out and the y's cancel out. So just like we talked about in the previous example, if both variables, if all your variables disappear while you're trying to solve the system of equations, it is going to be a special case. It will either be infinitely many solutions or no solution. So here what's going to happen is both variables cancel out and you get 0 since everything disappeared over here. On the right hand side you get 12 plus 3, which is 15. And so you said that what I was going to say is be sure you do that correctly, because even if you get the right answer from this, if you didn't, because sometimes I have students that don't add these and they put 12 here or they put 3. I take off a point for that because, you know, again, while it might still give you the same result in this problem, those kind of mistakes are going to lead to wrong answers in a lot of cases. And it just so happens you would still be okay if you put a 3 or a 12 here. It's still a mistake. So be careful not to make that mistake. All right, so you get 0 equals 15, which is false. All right, so if all your variables disappear, you get something that's false. That means there's no solution, which they worded a little bit differently here. The solution set is the empty set. That just means there's no solution. And when there's no solution, just go ahead and write that on the screen. When there's no solution, that also means it's an inconsistent system of equations. All right. So far, some weird fringe cases have been all of our problems, but hopefully this will be a more normal type of problem. And normal means you work it out, you get an answer. So I think that's what will happen for number 5. So here we're going to use the addition method, the elimination method, not only because it's in the directions, but that's really the best way to approach this problem. So I picked these problems carefully where the directions kind of match the way the problem should be done. So I really would follow the directions for the method that you use. Here we want to make sure a variable gets canceled out. We have 2x minus 5y equals 23. We have 3x plus 7y equals negative 9. And I want to add these 2 equations together, but in order for that to be effective, I need a variable to get canceled out in the process. And as written, neither variable is going to cancel out. And so I have to do some work here. And the first step is deciding which variable are you going to work towards getting to cancel out. You could do x's. You have 2x and 3x. It's not a bad choice. Either way, either variable we choose is going to be about the same amount of work. But what draws me to the y variable is that one's already negative and one's already positive, because that is a requirement for a variable to get canceled out. You need one to be a negative and one to be a positive. Y already exhibits that property, and so I'm leaning more towards having y cancel out instead of x. Now, if I want the y's to cancel out, I need them to have the same number here as well. And so I have 5 and 7. So what's a common number that both of these could be multiplied to? It's just like finding a common denominator. The answer is 35. I can make this a 35 by multiplying the top equation by 7. So I can't just multiply the y by a 7. I have to multiply the entire equation by 7, but that'll make this a 35. And I can make this a 35 by multiplying the bottom equation by 5. So I have to change both equations. It's really kind of the worst case scenario. What I end up getting here is 14x minus 35y equals 7 times 23 would be 104. I think that'll be 161. Hopefully, we'll see. If this doesn't work out nice, I'll go back and confirm these calculations, but pretty sure that's right. And the bottom one will be 15x plus 35y equals negative 45. All right. So now, when I add these equations together, the y's will cancel out. So now I'm ready to go ahead and add these together. I'll get 14x plus 15x. That's going to be, I almost put 19. But that should be, so I did this one pretty quickly, which I impressed myself with. And then, sorry, I keep hitting the microphone. And then I can't do this simple addition here. But it should be 29x. The y's cancel out. And when I add these together, I'm going to get 116, it looks like. Again, I'll find out if I'm right or wrong at this point, because your answer can be a fraction. That can happen with system of equations. But normally, again, this is more like game theory than like math knowledge, because any answer is possible here. But just based on my understanding of the types of problems that MathXL likes to generate, if you're going to get a fraction, it's going to be a nice type of fraction, like 1/2, 4/5, something like that. I'd be really surprised to get a fraction that was 116 over 29 that didn't reduce. So if you get some crazy fraction with a denominator of 29, that's a bad sign. So I'm guessing these have to divide evenly, or if they don't, I made a mistake and I'll have to go back and try to fix it. All right, so divide by 29 on both sides, and we get x is equal to, let's see, so 30, if it was 30 and 120, that'd be 4. So I'm guessing it's 4. So 29 times 4. I'm really being lazy and trying to avoid grabbing my calculator. So this will be 36, carry the 3. That'll give me 8 plus 3, which is 116. So perfect. So you get x is equal to 4. All right. Now, we're not done yet because that's only half of our solution. We still need to get the other half. We need to find the y value. And we do that by plugging this value for x back into either of the original equations. You could plug it in here, but these numbers are inflated. They're bigger than they otherwise would be. I don't want to deal with extra big numbers. I want to go back to where the numbers are smaller. And I was going to use the top equation, but really the bottom equation looks a little friendlier. These are both positive. This number is smaller. So I'm going to use the bottom equation. But in theory, it doesn't matter which equation you use. You will get the same answer for y either way. It's just a matter of what do you think will be less work. All right, and so we're going to get 3x plus 7y equals negative 9. Now, I just feel like this one looks a little less treacherous, a little bit easier going, and so I think it'll be less work. So I'll plug in 4 for x, and then I'll solve for y to find the value for y. So I'll get 12 plus 7y equals negative 9. Subtract the 12 to the other side. I get 7y is equal to negative 30. Did I do that right? Okay, why did I put 21? I think I thought ahead of the answer, right? Because negative 9 minus 12 is negative 21. So I think I meant to put negative 21 here as my answer. And so I wrote the number down a little bit sooner than I intended to. So it's just weird because subconsciously I had the answer already, but consciously I wasn't quite there yet. So it's kind of a weird glitch with me. All right, so this should be minus 12. And then when I subtract, I get negative 21, right? And then I divide by 7 on both sides. Oh, sorry about that. I'm at the boundary of my window of recording, and I'm sorry, I moved it a little bit. Let me just scroll down so I have a little bit more room. All right, so we divide by 7 on both sides. And then the 7's here cancel out, and I get y is equal to negative 3. And now it's glitching on me. Undo those marks. Y is equal to negative 3. And so my final answer should be as an ordered pair. X goes first, so 4, comma, -3. All right. And so which option do we choose here? We choose option A because we got an answer. And then you put the answer. If you're on Math Excel, you type it into the box here. If you're not on Math Excel, if you're on paper, this is fine. You don't need to actually write it over here as well. You can just leave it on your paper. You do need to respond to this part, though. Is this inconsistent, independent, or dependent? The answer in this case is independent. So if you get one solution, if you get 2 solutions, if you get 5 solutions, any of those cases, it's independent. It's inconsistent if there's no solution, and it's dependent if there's infinitely many solutions. Right. I don't think, did we have that up here? Okay, we did, but we answered it. Okay, I couldn't remember if I answered that or not. All right, so let's look at number 5, probably the toughest problem on the test in terms of, amount of work. This is going to take a little bit of time, so I apologize for that. But there's just no way. I guess there is a way around it. Maybe if you use matrices, which is what chapter 6 is about, which I'm not going to push us towards this semester. There's many semesters where I don't even get to chapter 6 anyways. And given the circumstances, I don't want to push harder than I need to. Chapter 6 is just the same kind of problems. It's system of equations, linear equations like number 5, but you learn a new method for solving them. So instead of what we're about to do, instead of graphing, instead of algebraically like eliminating variables, you can use matrix operations to solve the system of equations, and it's a little more efficient. It still takes a lot of paperwork. You'll have a lot of space on your paper that gets taken up, but it's worth looking into if you have the time, and you might find you prefer that method to what we're about to do. So what we're about to do, first of all, these numbers are kind of awkward. They're just numbering the equations. They're not part of the equation, so you're not multiplying this by 2 or anything like that. You have a system with 3 equations and 3 variables, and these are linear equations, by the way. You have x plus y plus z is equal to -11. You have 2x plus 4y plus 2z equals -32. You have -x plus 9y minus 3z equals -33. So the process we talked about for solving, especially in a case where it's a pretty generic run-of-the-mill type of this problem, is to first use 2 equations to eliminate 1 variable. You get to pick. It's completely up to you. Which 2 equations, which variable do you want to eliminate? So in evaluating the equations and the variables that I see here, one really stands out to me as an easy target, and it's x using the first and the third equation. I'm sorry, I didn't mean to write there. So this and this, it's set up to cancel out immediately. I don't have to do any work. So that looks like the easiest path to go with here. It looks like the easiest path to take. That's what I meant to say. All right, so for step 1, I'm going to use the first and third equation to eliminate x. Those were all completely within my freedom of choice, right? I could pick any 2 equations, any variable. So I'm going to write the 2 equations over here side by side, one underneath the other. Maybe that, I guess I was going to say the same thing, but that's not really the same thing, is it? Side by side would be, left and right. So this will be one on top of the other. So that's the first equation. The second equation is -x plus 9y minus 3z equals -33. And I can just go ahead and add these together. I don't have to do any preparation because x is already set up to cancel out. So the x's will cancel out. I get 10y minus 2z equals -44. All right, so that's the result from step 1. Step 2, now here we run out of flexibility. For step 2, you have to use a different pair of equations to eliminate the same variable. So I will see students on this problem where they use a different set of equations, but they eliminate y this time, or they eliminate z, because again, maybe there's an easy way to do that, but it doesn't do you any good with your first step. You have to get another equation with the same 2 variables. You want to get another equation with y and z, which means x has to get eliminated in the second step as well. So we have to eliminate x. We don't have a choice this time. And we have to use a different combo. We can't use the 1-3 combo again, which was the easy one. We'll have to use a different combo. So either 1 and 2 or 2 and 3. I got to get 2 into the mix. The easier one to me, it looks like, to eliminate would be the third one, the second and the third one. So this one and this one, because this one's already negative, this one's positive, so they're already opposite sign. And it's going to be pretty easy for me to make a 2 here. All I have to do is multiply this bottom equation by 2. And then the x's are ready to cancel out. So it's going to take a little bit of work, but not too bad, right? So I'm going to use equation 2 and equation 3 to eliminate x. All right, and so I'll have 2x, I'll just write the equations down here. 2x plus 4y plus 2z equals negative 32. And then I'll have negative x plus 9y minus 3z equals negative 33. I want x to get eliminated. Not that I want x to get eliminated. I have to eliminate x. And for x to get eliminated, I need a 2 here. So I'm going to multiply this by 2, which means I multiply the entire equation by 2. Both sides of the equation. So another common mistake I'll see students make is they will multiply the left-hand side by 2, but forget to multiply it to the right-hand side. So make sure you're multiplying it to both sides of the equation. So again, this problem's kind of messy. There's a lot of steps. I'm going to move back over to the middle here. I'm going to copy the first equation down because I'm not changing it. So I'm just going to copy it over here. 2x plus 4y plus 2z equals negative 32. But the bottom equation is going to change because I'm multiplying everything by 2. So I get negative 2x plus 18y minus 6z, because everything here got multiplied by 2, equals negative 66, because I have to also multiply 2 to the right-hand side. Now I can add these two equations together. The x's will cancel out just like I needed them to. And then I'll have 22y minus 4z equals negative 98. And so this is the result I get from step 2. All right, so I don't know if I can delineate the areas where the steps are occurring, but this is step 1. This over here all is step 2. All of this over here. Said the words backwards. You get more self-conscious. You know, if like I'm teaching in class, it's like if I misspeak, if I don't use the best words possible, it's not a big deal. But when it's being recorded and you know it's going to kind of exist forever, you get a little more self-conscious about how you say things. So I'm sorry, I keep correcting myself. I probably should just let it go. Step 3 is to use the results from steps 1 and 2 to solve it as a system of equations of 2 variables. Because you have the same 2 variables, you just need 2 equations to be able to solve that as a system of equations. So it's crazy, but step 3 by itself is like an entire problem from section 5.1. It's a system of equations of just 2 variables. So I'm going to write them down here. So we'll have 10y minus 2z, sorry, I was about to put x for some reason, minus 2z equals negative 44. And I'll have 22y minus 4z equals negative 98. And I want to solve this as a system of equations of 2 variables, just like I would in section 5.1 in the previous section. You can either use addition or elimination method, but I'm going to tell you most of the time in section 5.2, you want to stick with elimination method all the way through. That's what we used in step 1. That's what we use in step 2. It's probably going to work best in step 3 as well. So we have to make a decision. Which variable do we want to try to eliminate? And I think there's a pretty obvious choice here. Z is going to be the easier one to cancel out. Y would take a little bit more work. So I've chosen, it's my choice, but I'm going to choose the easy one. I'm going to eliminate z. In order for z to get canceled out, I need them to have the same number, so they both need to be 4, which means I need to multiply the top equation by 2 to make this one a 4. Sorry, to make this one a 4 to match this one. But also, if they're both negative, they don't cancel each other out. So I also need this to become a positive 4. And so to change the sign of this, I'll need to multiply by negative. So negative 2 times negative 2 would make this a positive 4z, and then the z's will cancel out. And so I don't need to change the bottom equation. So I'm going to rewrite the top equation over here, multiplying it by negative 2. So I get negative 20y plus 4z equals negative times a negative will be positive. 2 times 44 is going to give me 88. All right, the bottom equation will stay the same. So I'm just going to copy it over. 22y minus 4z equals negative 98. And now I can go ahead and add these two equations together. And I'll need some more space to continue working. And so the z's will cancel out. I'll get a nice number, because I was getting a little bit worried here with 22 and 98. I'm like, oh, I hope this is going to work out nice. And it does, because when with this one being negative, you get 2y. As long as this is even, you get a nice answer. Not that it has to be nice, but it's kind of what you're expecting here. When you add these together, you get negative 10, another reasonable result. So it's not like a humongous number. You divide by 2 on both sides, you get y is equal to negative 5. So finally, we get a result. It takes a long time to get there, but you finally get a result, negative 5. Now, what you want to do is you don't want to run back to the beginning of the problem and plug this back into one of the original equations at the beginning. You want to finish solving this system of equations here, which means I can still get z out of this setup. So extract all the information you can out of this. We're not done yet, right? We have negative 5 for y. Let's also get z while we're here. So I'm going to plug this back into one of these two equations. I'm feeling like the top equation looks a little friendlier. The numbers are smaller. So I'm going to plug this back into the top equation so I can find z. So I'm going to get 10 times in place of y. I'll plug in negative 5. It's kind of a weird looking 5. Let's try that again. All right. Minus 2z equals negative 44. And then we'll solve for z. So we'll get negative 50 here minus 2z equals negative 44. And then we will add 50 to both sides. So I'm sorry, I feel like I have to give a play-by-play, even though at this point it's probably obvious what to do and you don't need me to describe every step. I don't know how else to proceed. So divide by negative 2 on both sides, finish out that play-by-play, and we get z is equal to negative 3. All right. So now we have y and we have z from step 3. Now we're ready to go back to one of the original equations with both of these pieces of information, and then we should be able to find the remaining value, which is the x value. All right, so if we go back to the original equations, we want to pick the easiest one to work with. Again, in theory, you can use whichever equation you want. Any of them will give you the same answer for x. So let's pick the one that will be the easiest to work with, which is clearly the top one, the first one. X plus y plus z equals negative 11. That's what I'll use for step 4. So I'll put that right here. X plus y plus z equals negative 11. And I'm going to plug these two numbers in for y and z, excuse me. All right. So for y and z, whoops, I meant to switch back to the pen. All right. So I'm going to plug this in for y. Okay, that did not go well. What did I do? Okay. Use a different color, that might also help. Plug that in for y, we'll plug this in for z, and so we'll get x plus negative 5 for y plus negative 3 for z equals negative 11. When you combine these together, you get negative 8, so I'm just going to write it as minus 8. And so you get x minus 8 equals negative 11. You add 8 to both sides, and you get x is equal to negative 3 also. All right. And so now we have our solution to the system of equations. Notice it's singular, right? Even though there's 3 values here, those 3 values together make one solution to the system of equations. And we write that one solution as an order triple. So x comma y comma z is the order you want to go in. So it's going to be x first, which is negative 3, y, which is negative 5, and then z, which is again negative 3. And so this would be our solution to the system of equations. All right, so for number 6, we have another system of equations. There are, see, I don't know, the setup's a little bit weird. Okay. 3 variables, but only 2 equations. So anytime that's the case, the general rule of thumb is however many variables you have, that's how many equations you would need to have a solution, have one specific solution to the system. If you only have two equations like we do here. So we have three variables. I guess let's kind of back up there, get more specific. In this problem, we have three variables. So we would expect there to be three equations for there to be a solution. Since there's only two equations, that's not going to be enough information to narrow it down to a specific solution. So right away, before I even start this problem, I know there's going to be infinitely many solutions. That just has to be. Okay, maybe I shouldn't say that. Let me back up a little bit. It could still be no solution. That can happen. You know, you could have two equations where there's still no solution at all. But most likely, there is going to be infinitely many solutions. And that is what you're going to find with number 6. So on the exam, when you take the exam, again, I'm giving away a lot of information here. Number 6, the answer is going to be B. It's going to be infinitely many solutions. But you'll still need to find the details of what those infinitely many solutions are like. You know, you have to find the pattern. As I mentioned earlier for question number 2, just because there's infinitely many solutions doesn't mean just anything works, right? There's a certain pattern to the solutions that will work. You know, how do I want to say this? There's a certain pattern to the order triples that will work as solutions to this system. All right, so to find that, what we want to do is just the best we can, right? We only have two equations. Let's just see what we can do with that. And the best we can do is to at least cancel out one variable. That's usually the best you can do. So I want to make sure that when I add these two equations together, a variable will get canceled out. Now, in this case, we actually luck out and we get a little bit more to happen than just one variable canceling out, but you can't guarantee that. So if I gave you two random equations, the best you could really hope for is to cancel out one variable. If you get two variables to cancel out, that's just lucky. You got a nice problem where that happens, but you can't expect that to happen given two equations. So I hope that's clear. All right, so here I see that the y's are going to cancel out. I don't have to do any work to make sure that they cancel out. I don't know, I'm sorry, I feel like I'm just a little bit out of frame here. I keep seeing my camera, but then this gets in the way. I'm sorry. I don't know. It's vanity, I guess. So the y's are going to cancel out, but I look out and the z's also cancel out. So that's going to make things a little bit easier to manage. So let's just go ahead and copy these equations over here. I've belabored the point enough. Let's just actually do the work. So let me write the equations down. Maybe I should have said them as I wrote them. So we have negative 2x minus y minus z equals 8. We have negative 4x plus y plus 2z equals 16. Because I see a variable will cancel out, I'm just going to go ahead and add these equations together, right? And so we get negative 2x minus 4x, which is going to be negative 6x. The y's cancel out. That was the one I noticed would cancel out right away. But in addition, this is a bonus, the z's also cancel out. And so I get two variables out of the way at once, which again, like I said, normally isn't possible. Here, we add these together and we get 24. So make sure you add those together correctly. With two variables out of the picture, I'm only left with x, so I can solve this for x. I'm going to actually get a value for x, a result, right? I divide by negative 6 on both sides, and I get x is equal to negative 4. So while, it's kind of a weird thing, but while there are infinitely many solutions, all of them have to have an x-coordinate of negative 4. If the x-coordinate is not negative 4, it will not be a solution to this system of equations. And so I'm going to put negative 4 here as part of my infinitely many solutions. And by the way, if there was no solution, we wouldn't have even gotten this far. What would happen if there was no solution is that all three variables would cancel out at once. And then you'd have something that's not true. And then that's how you would know that there is no solution at all. So if you're getting anything for x, that automatically rules out the no solution thing. Pretty sure that would be true. All right. So now that we know what x is equal to, what do we normally do when we get a result? We plug it back into one of the original equations. So I'll plug it into the top one. We'll get negative 2 times negative 4 minus y minus 2z is equal to 8. And what I'm really interested in, especially if you look at the way this is set up, we already have z here as z. What I'm really interested in is the y variable. You know, what's going on with the y value? And so that's what that's what I'm hoping to find out from this part of the investigation, right? And so I plug in negative 4 for x. I get negative 2 times negative 4. That's going to be positive 8 minus y minus 2z equals 8. And this problem is And this one doesn't have alternates. So it's a pretty, like once you've done the problem, it's going to work out the same way every time on the test. So you can really over prepare for this one and make sure you're ready for everything it's going to throw at you, because another kind of weird thing that happens with this problem is that these numbers are going to cancel out, right? You subtract 8 to the other side, the 8s cancel out, and you get negative y minus 2z is equal to 0. And like I said, what I'm really interested in here is the y value. What's y supposed to equal? So I'm going to solve this for y by adding the 2z to the other side. And you get negative y is equal to 2z. And then you divide by negative 1 on both sides to get y by itself, and you get y has to equal negative 2 times z. And that's unfortunately the best resolution that we're going to get. We're not going to be able to resolve it down to a single value. What we're being told is that the y coordinate has to equal negative 2 times the z coordinate. And so what that means is the z coordinate can be any number we want. So we're free to choose z to be equal to 1, z can equal 2, z can equal 3, but whatever value we choose for z, the y coordinate has to be negative 2 times that value. So we do not get a choice for the y value. The y value has to be calculated based on this formula. So z is free. We can choose that to be any number. That's where we get the infinitely many solutions from, right? There's an infinite number of choices for the z value. So I can pick z to be any number I want. I can get an infinite number of solutions that way. But the y coordinate has to equal negative 2 times the z coordinate. You cannot pick that to be anything that you want. So what we're going to do is plug that in to our answer over here. So for our ordered triple, the x coordinate always has to be negative 4. Then the y coordinate has to be negative 2 times the z coordinate. And the z coordinate can be any number that we want. Right? Z can be any real number. And that's how we get an infinite number of solutions. All right. So that is a dependent system when there's 3 variables. Really pretty interesting kind of problem. And like I said, you can really make sure you're over prepared for that, because number 6 on your test is going to work out like that every time. So be ready for it. But don't just memorize. I don't know if you could memorize the answers, but you know, my requirement, I don't know if somebody else is watching this video, they might be thinking like, that's not fair. Their teacher's basically telling them what's on the test. The numbers will be different, and I still require work to be shown. So even if it's the same exact problem type, the numbers are always going to be different. And I don't let my students get away with just memorizing this number goes here, this number goes here. They still have to show the work to get to that result, or they don't get credit. So, but it does help to have that predictability, right? The problem's going to have the same surprises every time. So once you learn those surprises, they're not surprises anymore. You can be ready to handle them, but you still need to actually go through the steps and hopefully understand how the steps work. Anyways, number 7 is a word problem. The city zoo has different admission prices for adults and children. By the way, this problem was on the homework for chapter 5 in section 5.1, and it was in my lecture video. And so hopefully you've seen this problem a couple times already by now, and you see it's going to be on the test. So, but hopefully you're feeling prepared for it since you've encountered it multiple times. The city zoo has different admission prices for adults and children. When 3 adults and 2 children went to the zoo, the bill was $78.37. If 2 adults and 3 children got in for $74.53, then what is the price of an adult's ticket? What is the price of a child's ticket? So that last part really gives away the 2 unknown values, which you will need to use variables to represent. So the price of an adult's ticket, I need a variable to represent that. You could just use X. That's a pretty generic choice, and I don't mind generic choices in a lot of cases, but for this problem, for whatever reason, I like to use A to represent that unknown value so that I remember that this is for the adult's ticket. The other way you can kind of not worry about it is, as you would expect, the adult ticket's going to be more than the child ticket. And so you can just use X and Y and just remember the bigger one's the adult ticket, the smaller one's the child's ticket. And here for child's ticket, I'll use C to represent that. So I have 2 variables, which means how many equations do I need to have to get a solution? I need to have 2 equations. And that's exactly what you're getting here in these 2 statements. So the first sentence here, 3 adults and 2 children. So how much are they going to have to pay in total? they'll have to pay 3 times the price of an adult ticket for all 3 adults, plus 2 times the price of a child's ticket for both of the children. And then that total, we're being told, is $78.37. Sorry, that got erased there. And so that's one equation. And I used y. So I just made a big point about using A and C to be specific so we remember which one's which. And then I switched to y for some reason, but that should be C. Sorry about that. All right. And then the second statement, same idea, 2 adults. So they'll have to buy 2 adult tickets. And then 3 children, which means they'll have to buy 3 child's tickets. And we know the total for that purchase was $74.53. So there's your 2 equations with your 2 variables. So you should be able to solve it and get answers for the value of A and the value of C. I would recommend in this case using the elimination method rather than the substitution method, because solving this for A or solving this for C doesn't look like it's going to be very easy going. And so I think the easier path here is going to be, let's eliminate, even though it's going to take a little bit of work. So first thing we have to decide is which variable do we want to eliminate, A or C. It doesn't really matter. It's the same amount of work either way. I will choose to eliminate C, just making a choice. In order for C to cancel out, I need these to become the same number. I can't make the 2 into a 3, but what I can do is change both of them so that they become the same number. So I'm going to change both of them to become a 6. It's just like doing a common denominator, right? So what's a common number that 2 and 3 can both be multiplied to? They can both be multiplied to a 6. I can make the top one a 6 by multiplying by 3. I can make the bottom one a 6 by multiplying by 2. In addition to that, in addition to getting them to be the same number, we also need them to be opposite sign of each other. So if they're both positive, they're not going to cancel each other out. So I need one to be positive, one to be negative. So I will leave the top one positive. I'll make the bottom one negative. In order to multiply to these, to make these 6s, I have to multiply it to the entire equation, right? So when I multiply by 3 here, it's not just the C that gets multiplied by 3, it's everything that will get multiplied by 3. So I'm going to have to invade the space for question number 8, but I'm going to do this down here. So for the top equation, I get 9A plus 6C equals, now I've really managed to avoid my calculator up until this point, but I really feel like I'm out of my league here with this calculation. Okay, and then you just saw the game that I have up and haven't had a chance to play yet. I'm hoping to play after I finish recording this video. I should have just logged out of it. And so we'll get 3 times 78.37. All right, which is going to give me 235.11. All right, so I'll get 235.11. For the bottom equation, we multiply 3 by -2, so we get -4A minus 6C equals, again, I'm not up to the task, I'm just going to multiply here, and so we're going to have 2 times 74.53. And you might object and say, wait, Mr. Fallon, it's supposed to be -2, but I'll just make it negative, right? I know negative times a positive is going to be negative, so I don't need to have that in my calculator for me to know that. What I don't know is 2 times 74.53, right? And that's what I'm about to find out. So it's 149.06, but it will be negative, right? So negative 149.06. Now I can add these 2 equations together and know that the C's are going to cancel out. So I get a variable to cancel out. So I'll get 5A, right? 9A minus 4A is 5A, equals, I'm going to subtract these. Let's see if I can do this without a calculator. This will be 0.05 here for the change, for the cents. Here I need to borrow 1, so it'll be 15. 15 minus 9 is going to be 6. I borrowed 1 here, so there's 2 left. I'm going to have to borrow another 1 here to make this subtraction happen. So it's going to be 12 minus 4, which is 8. And then 1 minus 1, the 1's go away. So this is what I get. And then to solve this for A, I will divide by 5 on both sides. And I get A is equal to, I think I can do this without a calculator. 5 goes into 8 one time. You have 3 left over. You bring down the 6. 5 goes into 36 7 times. And you'll get 35. So 36 minus 35 gives me a 1 left over. Point. You bring the 0 down. 5 goes into 1 0, which is 10, 2 times. And then there's nothing left over from that, but you still have this 5 here, so you bring that down. 5 goes into 5 one time. So you're going to get $17.21 as the price of the adult ticket. I still need to find the price of the child ticket, so make sure you put these in the right box. On your test, if you put these in the wrong box, I might take off a point because it maybe indicates you didn't know which one was which. Or it could just mean you were just being a little bit careless and you knew, but you just didn't pay attention. So pay attention. Adults ticket $17.21. Plug that into one of the original equations. I'll just plug it into the bottom equation, I guess. Doesn't matter which one. It looks like the same amount of work either way. So I'll plug in $17.21 for A, so 2 times that, plus 3C equals 74.53. And then we'll have to do the arithmetic on this. Now this I think I could do without a calculator too, because 2 times 17 I know is 34, and 2 times 21 is going to be 42. So that was a pretty easy one to do without a calculator. 74.53. I'm going to subtract that over. Sorry, there's kind of a stray mark there. That's not a decimal. The decimal's right there. So I'm going to subtract 34.42 over to here. And I get 3C is equal to whatever this is going to be. It's going to be 1, 1. That worked out pretty nice. 0, 4. So 40.11. And then I'll divide by 3. And I'll get the price of a child's ticket. I'll write it down here. 3 goes into 4 one time. Bring down the, well, let's say this. 3 goes into 4 one time. You get 4 minus 3, which will be 1. So the remainder is 1. You bring down the 0. 3 goes into 10 3 times, which gives you 9. 10 minus 9 also has a remainder of 1. You bring down the 1. 3 goes into 11 3 times, and you get a remainder of 2. 11 minus 9 would be 2. You bring down the 1, you get 21. 3 goes into 21 7 times. So just use a calculator if that didn't make sense. But I'm basically doing long division, but I'm just doing it mentally. And that's taken some practice, but I've gotten okay at that. So that's the price of a child's ticket. So we get 13.37. All right. All right. So I think we're pretty much done with all the, oh no, I thought this was, I see the graphing down here. So I thought, oh, this is system of inequalities, but it's another system of equations. So these will take a little bit of work, but the last few problems are system of inequalities, which I think go a little bit quicker. You just have to know how to graph. And then once you graph it, you shade in the region. So again, because I'm already at 50 minutes, I feel like I'm really dragging here. I apologize for the amount of time I'm taking on this. It should have maybe only taken half this time so far. So for a system of equations with nonlinear equations, right? When I see this to the third power, it's a nonlinear equation. To solve that system of equations, you'll want to use substitution. So we haven't really done much of that in this test so far, but in this case, you want to substitute. So I'm going to take what y is equal to from the top equation, plug that into the bottom equation. And so I'm going to replace this y here with 9x to the third power. So I'll have, in place of this y, 9x to the third power. The rest of the equation stays the same, equals 36x. And in this case, what I'm coming up with is a polynomial equation to solve. Now, I just want to warn you that there's probably some alternate questions, so it may not look exactly like this when you take your test. There could be square root equations, there could be logarithms. I think I have some different possibilities here, so just be prepared for that. It could be absolute value, that's another one I think. So it's just going to randomly pick one of those types. This one happens to be a polynomial equation, so the way I'm going to solve that is to get 0 on one side and to factor the other side. So I'll subtract the 36x over here. I guess I'll just go ahead and write it in, even though it's going to be kind of messy looking. And I'll get 9x to the third power minus 36x equals 0. You want to get it equal to 0 first. Then you can factor this. Worst case scenario, which you should not encounter, would be p's and q's, doing synthetic division like we learned in chapter 3. But this one we can factor without all that. We just factor out an x and a 9, right? Because 9 is a common factor here. Let's make it as easy as possible on ourselves. So factor out a 9x, and we'll have x squared minus 4 left over. The x squared minus 4 can be factored as x plus 2 times x minus 2. And then to get our solutions, we set each factor equal to 0. The 9 can be ignored because 9 as a factor doesn't give me a solution, right? If you set 9 equal to 0, there's no solution to that. But you set x equal to 0, so you get x is equal to 0. Here you set this equal to 0 and solve. You'll get x equals -2. That's a way I can save a little bit of time, is just skipping to the result there, because you should know how to get there. And then setting that equal to 0, solving for x, you get x is equal to 2. Now, you might say, okay, I solved the equation, I'm done, but you're not done solving the system of equations, right? These are the values for x. We also need the corresponding values for y. So this one we kind of look out by having 3. You're not as likely to make this mistake. But when there's only 2 solutions, a lot of students will take those 2 answers and put them together as an ordered pair. But these are x values. You can't put 2 x values together as an ordered pair. It needs to be an x with a y. Right? So I want to take an x and a y and put those together. So I need to find the corresponding y values for each of these, right? So this x should have a y. I put the answer, which is weird because I wasn't even thinking about it, but I put it there anyways. I want to put a question mark, right? This x should have a y. This x should also have a different value for y. And this x should have a different value for y. So I have 3 different y values that I need to find to pair with these 3 different x values. And the way you're going to do that is just like we've done in previous sections. You're going to take these values for x, plug them back into one of the original equations so that you can find the corresponding value for y. You pick whichever one you think is going to be easier to work with. I'm not really liking that to the third power thing there. So I'm going to use the bottom equation. It's the linear one. It's going to be easier to work with. So I'm going to use y equals 36x, and I'll plug each of these values of x in here to find the corresponding value for y. I'll start with 0. So we're going to get y equals 36 times 0, which I already kind of gave away is equal to 0, right? So here y is equal to 0. For this one, we'll get y equals 36 times -2, which is going to be -72. Kind of a big number, but that's the value for y there. So here we get -72. And here, I'll plug in 2 for x, and I'll get y equals 36 times +2, which is going to be +72. And so that's what I get here. And so my final answer, the way you're supposed to organize this, especially if you're typing it into Math Excel, is you want to put all these together as ordered pairs and then put them all together when you type it into that box by separating them with commas. So the way it has to look on Math Excel is you'll have 0, 0. That's this solution here, 0, 0. You'll have -2, -72. Sorry, I couldn't quite see it there. -2, -72 would be another solution, pairing that x with that y. And +2, +72 would be another solution. And then you separate all those with commas. So this is how you would type it in to Math Excel. Now, they also want you to choose the correct graph that matches this system of equations. You're not really supposed to use this graph to solve it, so don't try to do that. It's really hard to tell where these are crossing each other. But what you should know is that the bottom equation is a line. It's a linear equation. The slope is positive, which means the line has to be increasing. Has to be going up as it goes to the right. So B cannot be correct, because here the line is decreasing as it goes to the right. So B is not the correct graph. And C cannot be the correct graph. So either has to be D or A. But the problem with A is that these graphs only cross one time, which means there would only be one solution to that system of equations. So A can't be correct. So it has to be, of course, the one that's the hardest to see here, which is D, right? It has the line that's increasing, and there's 3 solutions, right? There's 3 spots where the graphs are crossing each other, which corresponds to the 3 solutions that we found. So it has to be D. All right, let's take a look at number 9. Okay, it's the last one on this page. So same thing, system of nonlinear equations. We want to solve by substitution. So I'll start by taking the top equation, solving it for y. I'll do that, let me pick a different color, by subtracting x to the other side. So I get y is equal to 9 minus x. I will plug that into the bottom equation for y. And so I'll have, the x will still be there, but in place of the y, I will have 9 minus x. And then I'll still have the equals -10. All right, so I replaced the y, this is where the y was. I replaced it with 9 minus x because that's what I got from the first equation. And now I have this equation that only has one variable, so I can solve for that one variable. And you might think, okay, this shouldn't be too bad, but you should pretty quickly realize that this is not as simple as it might look. After you distribute the x, you get x squared here, which means this is a quadratic equation. So we're going to have to solve a quadratic equation to get my solutions here. And that means, just like we did in the last example, getting 0 on one side, factoring the other side. Factoring is always easier when x squared is positive. And so I am going to, even though it looks like it'll be a little extra work here, I'm going to add the x squared to the right-hand side. And since I'm moving that over to the right-hand side, I might as well move the 9x to the right-hand side as well. And so I'm going to get 0 on the left-hand side, which is a little bit unusual. Normally you get 0 on the right-hand side, but it doesn't really matter. And I think it's just an easy way to deal with that negative sign, moving both of these over to the right-hand side. And then put them in order, right? Because that's the other thing, is these are out of order. Now I can put these in the right order. I get positive x squared minus 9x. Sorry, it's starting to glitch on me because I've put a lot of writing on the screen and it starts to get angry when you have too much going on the same screen. And so we're going to solve this by factoring. Two numbers that multiply to negative 10 and add to negative 9 would be negative 10 and positive 1. And then we set each factor equal to 0. Again, I can save myself a little bit of time by skipping those details and just jumping to the result, which I think you guys are probably comfortable with as well. We get x equals positive 10, x equals negative 1. Again, don't fall into that trap of, oh, I have these two numbers, put them together. My solution's 10 comma negative 1. These are both x values. You cannot pair two x values together. X has to pair with a y. Right? And so for both of these, I should be finding a corresponding value for y. So this x value needs a y, and this x value needs a y. To find those values for y, we have to take these x's, plug them back into one of the original equations. I see the perfect spot right here to plug them in. This one's already solved for y, so let's plug it into this equation. Right? And so I'm running out of room here. I guess I'll just scroll down a little bit more. So we'll do that down here. I wanted to be able to see the equation, so I'll do it down here. Okay. So y equals 9 minus x. I'll plug in 10 for x. So we get y equals 9 minus 10, which is negative 1. And so we get the pair of 10 comma negative 1. That's one solution to my system of equations, but we have a second solution. Right? We'll get y equals 9 minus x, which means y equals 9 minus negative 1. The minus and negative makes that a plus. And so we get y equals 9 plus 1, which is going to be 10. And so this pairs together as negative 1 comma 10. Now if you think about it, you're really getting the same answers both times, right? They both have 10 and negative 1, but the difference between these two solutions is which one is x and which one is y, right? So in this case, the x is 10, the y is negative 1. In this case, the x is negative 1 and the y is 10. So that technically counts as two distinct different solutions, even though it's really the same numbers both times. All right, let's look at the next page. All right, so in this system of equations, we have one more left. It's, again, a nonlinear system. You can see that because you have x squared and y squared. And then for the bottom equation, it's y equals x. That's a linear equation. It's already solved for y. So again, using substitution, I'm going to plug that in to the top equation for y. And so the top equation will be x squared plus, in place of that y, I'm going to plug in x because the bottom equation is telling me y is the same thing as x. And so I'm going to replace the y with x since the bottom equation tells me they're the same. Equals 9. Right? And now I want to solve this equation for x. And this one, the answer is not going to work out so nice, but we'll combine like terms here. We'll get 2x squared is equal to 9. And then we want to solve for x. It's technically quadratic, but you don't have to factor it because there's no x term. There's just x squared. You can just get x by itself. So we'll divide by 2 on both sides. We'll get x squared is equal to 9 over 2. Take the square root of both sides. You get x is equal to the square root of 9 over 2. Please remember, when you take the square root of both sides, you have to do plus or minus. We've seen that enough times in this course. We're at the very end of the course. Last chapter, last test, and we've seen that so many times you should hopefully know it by now. So when you take the square root of both sides, plus or minus, and also, on the test, if it's on paper, I might let this slide. I might take off half a point for not doing something about this. but Math Excel probably would count it wrong, which is you can't leave a square root in the denominator. And you might say it doesn't even look like there's a square root here in the denominator, but there is. This square root applies to both the 9 and the 2, and you never want to leave a square root in your denominator. So you're supposed to rationalize the denominator here, and you could do that by multiplying by square root of 2 to the top and bottom. And so you get x is equal to plus or minus square root of 18. Oh, no. Okay, I made another silly mistake. I was going to just go with it, but it's just so much more work if I do than if I just go back and fix it. Well, I mean, I guess I don't want to fix it there either. Let's put that back. Maybe I do. Well, I can just write it here. Okay, sorry. I'm being indecisive. Square root of 9 is 3. I don't know. It just did not even dawn on me. But square root of 9 is equal to 3, right? And so let's go ahead and simplify that. And so we'll still have to multiply square root of 2 to the top and bottom, but now we'll have 3 square root of 2 instead of square root of 18, which we would then have to simplify, and that would be some extra steps, right? So I was trying to save myself some time, but I took a lot of time doing that. So this is what your answer needs to look like for the x values. And there's 2 of them, positive and negative. So we need to find the corresponding values for y, for both of these, right? So we have x equals positive 3 square root of 2 over 2. We also have x equals negative 3 square root of 2 over 2. I need to plug both of these back into the original equations to find the corresponding values for y. I will use the bottom equation because it looks a lot more friendly than the top one. And so I'm going to use this equation here. So I have y equals x. And it's kind of a silly thing that's happening, but this equation's telling you, as I already mentioned up here, that y will always be the same as x. X is always the same as y. So whatever you get for x, that's going to be your y value as well. Right? So when I plug that in for x, I get that y also equals 3 square root of 2 over 2. And when I do the same thing here, I get y is also equal to negative 3 square root of 2 over 2. Right? So whatever you get for x, that's going to also be your y value. Right? I guess if you really want to see, sorry, this is kind of messy, but here's the equation. I'm plugging this in for x. I get the same answer for y. Right? So my 2 ordered pairs are going to be, like I said, it's kind of a mess. 3 square root of 2 over 2 for x, comma, 3 square root of 2 over 2 for y. Right? That's one solution. My other solution here, let me scroll down a little bit so it doesn't get in the way of the camera, is negative 3 square root of 2 over 2 for x. That was this value for x, comma, negative 3 square root of 2 over 2 for y. And you'd separate those with commas if you're typing it into Math Excel. And so this would be my 2 solutions to that system of equations. For choosing the correct graph, hopefully you recognized that x squared plus y squared equals 9 is a circle where the center is at 0, 0, and the radius is 3. So if you look at these circles, only one of them fits that description, right? This circle is not at center 0, 0. This circle is not at center 0, 0, so we can rule those out. This one's also not at center 0, 0. Only this one is. So again, of course, the one that's the hardest to see is the correct one. So, but it's option D is the correct answer. All right. So let me see if I can do these quickly because I'm really sorry about the length of this video. I'm not trying to waste your time. Sketch the graph and I don't know what I'm saying now. Sketch the graph. It's already past 5 o'clock. I'm ready to be done too. Sketch the graph of the solution set to the following linear inequality. So it's an inequality is what I was trying to get at. The method I prescribed in section 5.5 for these problems is to solve each one for y if possible. So I'm going to solve this for y by subtracting x to the other side. I get y is greater than 4 minus x. Should be a minus sign there. All right. And then I will graph this as an equation. So I'm going to graph, so let me say that's step 1. I'm going to graph y equals 4 minus x. It's a linear equation. So we're graphing a line. The slope is negative 1. The y-intercept is 0, 4. So I'll start at 0, 4, which is right here. The slope is negative 1, which if you think of it as a fraction is negative 1 over 1. It tells me to go down 1 and to the right 1. So I'm going through that process quickly because by now, end of college algebra, you should be pretty comfortable with graphing lines, right? So especially if they're already solved for y. But one thing that is different here is when I go to connect those 2 points with a line, I have to ask myself, should it be a solid line or a dashed line? So this will be worth a point on the test. If you use a solid line here, you're going to lose a point. Should be a dashed line. And the way I know that is because there's no equals to here. So I'm going to graph this as a dashed line. And so I can't use my graphing tool or my straight line drawing tool because it only does solid lines for some reason. So I'm going to have to do this freehand. Oh gosh, that was really bad. Okay. So, and it should be a straight line. See if I can make this straight. Oh, this is going really horrible. Okay, I guess that's, okay, no, I can't live with that. Okay. Let's see, maybe if I just slow it down a little bit. So it should be, or maybe I should just do actual dashes instead of dots. Okay, try to make that line straighter than I just drew it. But like I said, I'm ready to be done. So I'm just going to leave it as is. All right, so there's the line that borders our solution set. So sometimes I'll have students on the test where they get to this point and they stop. And I'll give you 3 points out of 5 here because you solved it for y, you graphed it as a line, you knew it was a dashed line. That shows some knowledge. So I'll give you 3 points because there's kind of 3 elements there that you've acknowledged. If you shade in the wrong area, I will give you 4 out of 5 points because just knowing that you're supposed to shade in, to me, is an indication that you have an understanding of the problem. If you don't shade anything in at all, I wonder if you understand the concept of this problem. And so that's why it's, you lose more points. So if you're at this point and you're like, I'm not sure where to shade, so I just will leave it blank, that's a bad choice. Make a guess. Shading in something is worth more than shading in nothing at all. All right, so I'm going to shade in. In this case, we have to decide, should I shade above or below this line? The way you make that determination is by looking here when you've solved it for y, if it's a greater than or a less than. This is a greater than, so that means we're going to shade above. All right, so I'm going to shade above this line that I've drawn here. So I'm going to shade in here. Let's see if this will work. Okay, so this region right here. All right. So everywhere above that line, all of these points are solutions to that inequality. All right, so that's number 11. All right, let's move on to the next page. All right, so number 12 is the same question. It's asking us to sketch the graph of the linear inequality, but this one's going to be an unusual case. So number 12, when you take my exam, number 12 is going to be one of these unusual situations, but there's 2 possibilities. So again, you can't just memorize the way I'm doing this problem and assume that automatically is going to work on the test that you were given. You might have the alternate possibility. Either way, whichever one you end up getting, the quirk here is that this inequality only has one variable. My particular instance of the test has just x, but you could also have a problem where you have just y. And it's going to look a little bit different depending on which one you get. So if you just get x, what you're going to do is step 1, you're supposed to try to solve it for y, but this one cannot be solved for y. So instead, I'll just solve it for x. If I can't do step 1, I'll just do the best I can with what I have. I'll solve for x by subtracting the 2 to the other side, so I get x is greater than or equal to negative 2. Step 2, graph this as if it were an equation, so I'm going to graph x equals negative 2. So when it's just x and there's no y variable, this graph will be a vertical line. If you have the other version of this problem and you only have y as your variable, and there's no x, then you will be getting a horizontal line. So that's going to be the big difference. If there's just x, it's a vertical line. If it's just y, it's a horizontal line. All right. So this will be a vertical line through negative 2 on the x-axis. So here's negative 2 on the x-axis. I will get students on the exam where that's all they do. They put a point right there. And that's not the right answer by far. This is a line, right? Even though the equation only has one variable, we are working in a 2-dimensional world here. So when there's only one variable, the result is still a 2-dimensional object. I guess, I guess a line really is still just a 1-dimensional object, but it exists in a 2-dimensional world. So we need to draw this to fill in the 2 dimensions, right? And so this needs to be a line, not just a point, right? Because a point's, 0 dimensions. This should be a line when you're working in 2 dimensions. And so you want to draw it as a vertical line. And you still need to ask before you draw this vertical line, because I'm going to draw a vertical line through this point here. Should it be a solid line or a dashed line? Because of the equals to here, sorry, I should use a different color. Because of the equals to, this is going to be a solid line. All right, so I'm going to draw a solid vertical line through -2 on the x-axis. I'll go and use my line drawing tool since it's a solid line, and it's going to look like that. All right. Now we have to decide where to shade. So step 3 is do shade. Usually we ask ourselves, do we shade above or below? But that's only if you could solve it for y. If you can't solve it for y, you have to frame the question differently. Because I solved this for x, the proper way to ask the question is, do I shade to the left or to the right? So for greater than, I'm going to shade to the right because x values get bigger to the right. If I'm looking for values, what I'm really looking for here are all the ordered pairs where the x-coordinate is greater than -2. On this line is where the x-coordinates equal -2, but I want the x-coordinates that are greater than -2. The x-coordinates become greater to the right. The numbers are bigger for x when you move to the right of that line. So all of these points over here have x-coordinates bigger than -2. And so this is the region I want to shade in. And so again, I'll use my highlighter tool, try to stay in the line. I didn't mention that on the last example, but if you're a little bit careless and stray a little bit over the line, that's okay if it's just a little bit. But if you're doing like this, that's going to be a problem. I should have, I don't know, the erasing tool might not work as well as I want there. I shouldn't have done that. Okay. Yeah, so be careful to stay within the line within reason. If it's like this, I can let that go. All right. And so you just shade in the entire region over here. All right. Now when these overlap, it's going to be a little bit darker than it should be, but okay, you get the idea. All right, shade in this region. All right, so number 13, we have, again, just one inequality. So we haven't done a system of inequalities yet. I think that'll just be the last problem. So we're almost done. We've got 2 more problems. I'm really sorry about how long this video is. Again, step 1, we want to solve for y. Can't be done here. It's y squared. You don't want to deal with square roots in these inequalities. So we're just going to leave it the way it is. We can't solve it for x either. We're just going to leave it as is. So we're just going to skip step 1 and go right to step 2, which is let's just graph this as an equation. We're going to graph x squared plus y squared equals 81. And this is a circle. So if you didn't recognize it from the earlier problem, you definitely need to recognize it here. The center of this circle will again be at 0, 0. We know that because the formula we should be thinking of is this formula here. And the center is at h and k. But there's no h and there's no k here, which means they must be equal to 0. The radius squared is equal to 81. So to get the radius, you take the square root of that number, which tells me the radius is 9. And so I want all the points that are 9 away from 0, 0. So here's 0, 0. I want all the points that are 9 units away, diagonally and everything. But finding the distance diagonally, you know, how far is it 9 if I'm going in a diagonal direction? That's hard to do. So we want to do the easy points, which are straight up, straight down, straight left, straight right. So we'll go straight to the right, 9. That would be, so I know that's a distance of 9. Straight up to 9. Straight to the left, 9 units, and straight down 9 units. So those, I can be certain of those distances. And then such a big circle. It's going to be so hard for me to draw this, but you want to connect those points in a circular fashion. Don't make a diamond or a square out of this. It needs to be a round circle connecting these 4 points. I'm going to do the best I can. And also make sure you do either solid or dashed. This time it's solid because that's an equals to. So I'm going to draw a solid circle connecting these points. Okay, that didn't turn out too bad. I'm just going to do it in quarters here. And hopefully it'll be a circular shape when I get done with it. There we go. Okay, big circle. Then step 3, oh, this is just like, I feel like I'm being trolled here by this problem. Step 3 is, do you shade above or below? Now the easy one, the easy path for me would have been shading, I said above or below, but we can't do that here. The path would have been for me to shade within the circle, but unfortunately that is not the case for this one. So you don't decide whether to shade above or below because we couldn't solve it for y. So the proper framing for this question would be, do you shade inside or outside the circle? And for greater than, you're going to shade outside the circle, right? So we will shade outside. If it's less than, you want to shade within the circle. So outside the circle, which is just so annoying to have to shade all that in, but I guess let me do the best I can. And again, I'm trying to hurry and get done with this video, and this is just going to add time to it. So outside the circle this time. I feel like this has never happened before. I want to say every time I've done this problem in class or on a test, it's always been inside the circle, so I'm really surprised by this, honestly. So outside the circle, everywhere outside. All of these points would satisfy that inequality. Okay, so last problem. Let's get this done. Okay. This one is a system of inequalities. So we have a system this time. The way you manage a system of inequalities is you just deal with each individual inequality following the same steps. You're going to solve each one for y, graph both of them as equations, and then either shade above or below. But when you go to actually shade in, you have to make sure you're shading in a region that satisfies the above or below for both inequalities. So you have to pick one region that works for both of them. So for step one, for both of these, they're already solved for y. So that's going to be a big time saver. All right, step one is already done for both of these. I should have just put check marks there, but they're already both solved for y. Step two, I'm not going to write this out this time because, again, I'm trying to get done with this video. You want to graph both of these as equations. So to graph this as an equation, the y-intercept is 0, -3. The slope is equal to 1. And so we'll start at -3 as our y-intercept. The slope is 1, so we go up 1 to the right 1. We connect these 2 points with a line. In this case, it will be a dashed line because there's no equals to. And so I'm going to do a dashed line here the best I can. All right. Okay, that didn't turn out too bad. So that's graphing the first inequality. We'll go ahead and graph the second inequality as well. So again, the y-intercept here is 0, -1. The slope is -1, so think of that as -1 over 1. So we're going to start at -1 on the y-axis, 0, -1. The slope is -1, so we go down 1 to the right 1, and we hit the same point that we had for the first one, which is kind of nice. Again, a dashed line because there's no equals to here, so we'll draw this one as a dashed line, but I'll do a different color just so these stand out from each other. All right, and so it's going to look like this. I seem to have trouble going in that direction for some reason. All right, and again, a dashed line. And then step 3 is, where do I want to shade in? Well, if it was just the first inequality, y is greater than, I would shade above that line. And that's the black line. So I want to shade above the black line, but I don't want to shade everywhere and above the black line because I have to take the second inequality into account. For the second inequality, it's a less than, so I want to shade below. So I want to shade below the red line. So when I go to shade in my final solution, I have to make sure I'm satisfying both inequalities at the same time. So to shade in my final answer, I want to shade above the black line, but also below the red line at the same time. So there's only one region where both of those things can be done simultaneously, which is this region right here, right? This region is above the black line, but it's below the red line, right? So it's going to be this region here. Stay within the lines to the best of your ability, and only in this region do we want to shade it. And so that would be the solution set to that compound inequality. Thank you for watching the video. I'm sorry about the length of time that it took. If you have any questions, if you're one of my students, please contact me. Good luck on the exam.